Okay, probability notes part 2. All right, we're starting off with combinatorics. Combinatorics is using things like the fundamental counting principle, permutations and combinations to find all the equally likely outcomes. All right, example 4. What's the theoretical probability of getting dealt exactly 2 sevens in a 5-card hand from a standard 52-card deck? All right, so we're looking for the probability of getting exactly 2 sevens. All right, so we're going to get dealt 5 cards. So our 5 cards. All right, we want 2 of them to be sevens, and then the other ones we don't care what they are. So we could have an ace, we could have a king, we could have a 3. All right, so we're not worried about these other 3 cards. We want the 2 sevens. So let's get the 2 sevens first. Well, first off, there's 4 of each card. So there's 4 sevens. All right, the order we get them in doesn't matter. So we're going to use combinations. And we want 2 of them. All right, so this part gives you the 2 sevens. All right, now we still need 3 more cards because remember we're getting 5 cards total. All right, so we don't want any more sevens, so we have to get rid of those. So if we get rid of those, there's 52 cards in the deck. If we take out the 4 sevens, that leaves us with 48. All right, so 48 cards, other cards, okay? And of those, we want 3. All right, so my 2 sevens is this part of it, and my other 3 cards is that part of it. All right, and then I put that over 52, because there's 52 cards in the deck. Choose any 5. All right, and once I get that, now all I got to do is put this all in the calculator. All right, so in the calculator it's going to look like this. We got the C and the P in the calculator, so I'm going to go for under math. I'm going to go to probability, and there's C, enter, and 4C2, and I hit enter, and that gives me 6. All right, so that first part is 6 times, and then 48 C 3, enter, that's 17,296, and that is divided by 52 C 5, which is 2,598,960. Now, all I got to do is divide these. So I'm going to start off, I'm going to do the 6 times 17,296, and then I'm going to divide that by this answer. So it's going to hit second and answer and hit enter. And we get that it is approximately, well, 0.0399, which is approximately 4%. All right, so you got a 4% chance of getting dealt exactly 2 sevens. All right, and that's how you use combinatorics to do this. So we used combinations on this problem. All right, so there's 2 U-tries for you to do for those problems. All right, and then we have one last thing to do. All right, so geometric probability. This is just using your geometry formulas. All right, so what we have here is we have a batter strike zone. It's 15 inches by 20 inches tall. All right, so 15 inches by 20 inches. All right, so it looks something like this: 15 inches, 20 inches, and it's a rectangle. All right, and we want to know what's the probability that a randomly thrown ball from a pitching machine is a high inside strike. So, okay, so our high inside strike would be this rectangle in here. All right, and that rectangle is 4 inches wide by 5 inches tall. All right, so what we're looking for actually is the probability of a high inside strike, that would be the area of small rectangle, which is the high inside strike, over the area of the big rectangle. All right, so you're just comparing areas or doing areas. So we have this, we have the area of the small, which is 4 times 5, and over the area of the big, which is 15 times 20. If we multiply the 4 times 5, we get 20 over 15 times 20, and then you can see the 20s will cancel out, so this becomes a 1. So we get our answer 1 out of 15. And then if we do that as a percent, all right, we would do 1 divided by 15, hit enter, and it gives us 0.06 repeating, 0.06 repeating, which would be approximately 7% when you round it. All right, so it's about 7% chance of that happening. So again, some of the area formulas you're going to need. You're going to need the area formula for a circle. All right, area formula for a circle is pi r squared, and you'll need the area formula for a triangle. All right, so the area formula for a triangle is 1/2 base times height. All right, and then you're going to use your area formula for your rectangle, which we just did. Area formula for rectangle is just length times width. So these are the area formulas you're going to need for these problems. All right, so you're going to do the these two U-tries. So you got the 2 U-tries from the other one, and then those 2 U-tries to give you some practice at this. All right, and then I will give you the homework.